Students, I would like to continue my discussion in point group. Here in this video, let us do lot of examples which have been asked in various examinations. I have discussed the shortcut method to identify the point groups. Let us practice that shortcut with a couple of examples. Okay, let me do first this molecule CH4. If you have a molecule for point group identification, what you will search for first is it special groups, is it belong to special group. Okay, 4 that is 4 groups attached and all 4 groups are same, it is tetrahedral. Okay, another molecule SF6, this is also octahedral. Don't think that I give you this first in my discussion, therefore I discussed this first. No, whatever the molecule is given, first you have to think whether it belongs to special group or not. Okay, first check for special group. Second, check for linearity. Linear molecule. Third example I give you, carbon dioxide. Linear. If it is linear, draw the structure. Look at the center. Both sides are equal for the center. Therefore, D infinity H. Or linear or diatomic molecule. Diatomic molecule. Fourth example I give you, NO. Center, both sides are not equal, therefore it is C infinity H. Sorry, C infinity V. Sorry, C infinity H. I'm really sorry, C infinity. Infinity V, sorry, C infinity V, linear with the, okay. Another one, organic molecule like this, it is also linear, symmetric both sides, therefore D infinity H. Just 1 minute. Okay, 6th one, I2, that is II or Cl2 or Br2, all are symmetrical, D infinity H. Okay, now I will go to next kind of molecules. Another example, suppose you have a molecule like this, C, H, Cl, Br, iodine. All atoms are different. is not planar. It is not special case. It is not linear. It is not planar. Not special case, not linear, not planar. No any axis, only C1. If you cut any plane, you will not get the identical. Therefore, no sigma. Therefore, its point group is C1. Okay. Now I give you another structure. Look at here. A B beam C D. What is this? C is towards you, D away from you. A and these two B are on the plane of the board. Okay, just like this. See, just like this. Okay, one is away from you and like this. This is C and D like this. A and B, this away from you, A and B on the plane of the board. Clear? It is like this, A and B like this, A, B like this. Now you have no axis, but you have a plane. What is a plane? Suppose A, B here, both are plane. You have a plane like this. It is towards you, it is away from you. B here, you cut. When you cut, when you have a plane cutting C and G like this side is B, this side is B. Okay. Therefore, this molecule has a plane of symmetry, but it has no axis. No axis. Because if you rotate 180 degree, if you rotate 180 degree, what happens? 180 degree means it will come here, but the problem is D will come here, C will come there. It is not a identical shape. When you rotate the 180 degree, D will come here, C will come here, you will not get identical geometry. Therefore, it has only one plane, therefore it is CS. CS. Now, a molecule like this, OHCl. HOCl not a linear, very careful students. HOCl not a linear because of lone pair here. But HNCl are in planar. HNCl are planar. Planar means if a molecule is planar, it has a sigma plane, a plane. Planar means a plane is there. But you have no rotation. When you check for the angle, particularly for planar molecule, this is the x-axis. It has no x-axis because this side groups, this side no groups. Therefore, no axis this side. It has no axis like this because this side is L, this side H. And it has no axis like this. Therefore, when you check for possibility of axis, it may be x-axis, z-axis or y-axis. No need of rotation for checking if it possesses axis or not. No need of rotation. You just imagine an axis, look at this side, not equal. Therefore, it has no axis like this. Imagine an axis like this, look at the upside and downside, not identical, therefore no axis. You imagine an axis like this, right side and left side are not equal, therefore it has no axis, but it has a plane. What is a plane? Plane is molecular plane, the plane which contains all the atoms. If you have cut the plane, all the atoms, what is upside the plane? Nothing. Other side of the plane? Nothing. Therefore it has a molecular plane. Therefore it is also CS. It is also CS. Now, we can come with another example. See, another example. That is oxygen, oxygen. This hydrogen towards you, this hydrogen away from you. Just like this. Okay? Just like this. But this is also hydrogen, this is also hydrogen. Now plane, because it is just like this. Because of the rotation, because of the lone pair, there will be a shifting like this. Therefore, it is not planar. Very careful. It should not be planar. It should not be like planar. Because of the lone pair, there should be some non-planarity. Okay, lone pair is there. There will be no planarity. Okay. It has no planarity, but it has a rotation. What is a rotation? I rotate. It has. Look at here. I rotate like this. When I rotate 180 degree, it has no rotation like this, no axis, because this side it has no rotation like this. But if you rotate like this, rotate with respect to, bring this to here, C2 axis. Okay, when you rotate C2 axis, this entire group will come here like this, and this will go up. Okay, I will show you like this. Okay, if I rotate, this rotates, and I will get like this. Okay, this is C2 rotation. Therefore, it has a C2 axis. Now, another molecule, H3PO4. H3PO4. How do you write its structure? P double bond O. O H should be like this because of the lone pair. O H should be like this. O H should be like this. How it is? It is like this. Now H here, H here, H here, oxygen. Look at here. There should be an H will be like this. Can you imagine H like this? Here H, here an H, here an H. It is not like ammonia because of this H. But when you rotate, this red comes towards you like this. It has a C3 axis, but no plane. Therefore, this molecule is also C3 axis. Okay. Now, another one, BFFF. It's not special case, it is not linear, all are planar. First, you have to check whether it has C3 axis. Yes. In all other cases, whether H3PO4, H, and this example, it has only C3 axis, no C2, no planarity, nothing. Now it has C3 axis. Now second thing you have to check whether it has NC2 or C2. Yes, it has C3 axis like this, but it has C2 axis, one C2, second C2, third C2. Therefore, it has 3 C2. Therefore, it is a D group. Now, you have to check whether this molecule has planarity. Whether the molecule has any planarity. Yes, it is itself is a planar molecule. And that planar molecule, this sigma plane is the plane of the molecule, and that is perpendicular to principal axis, because your principal axis is like this, and this is your sigma plane. Therefore, it has H also. Therefore, it is D3H. D3H. Okay. The BF3 has D3H. Now we come to next example. NH3. What is the structure of NH3? H, H, H. First you have to check whether it has CN axis. Yes, it has C3 axis. Second, you have to check it has NC2 axis. No C2 axis. That should be perpendicular because your C3 axis like this. Your C3 axis like this. Now perpendicular should be, it should be the perpendicular. It's not perpendicular axis like this. If you rotate with respect to this axis, it will come here. Okay, it's not possible. It has C3 axis like this, but it has no axis perpendicular. Because when you imagine an axis like this side has hydrogen atom, this side has nothing. Therefore, when you rotate, you will not get the identical groups. Therefore, it has only C3 axis. Now, second is no C2, no C2, C2 not. Now, what is second? You will check whether it has sigma h. Is it sigma h? Sigma h means any plane perpendicular to the principal axis. It is your axis. You have no plane perpendicular to this axis. Because perpendicular plane should be like this. If you keep a plane here, down part is hydrogen, upper part nothing. Therefore, no plane. Therefore, no sigma h. Okay. Therefore, it is C group. Now you check. It is C group because of this. No sigma plane. Now you check whether it has vertical plane. Vertical plane means plane containing principal axis. Yes. It has a plane like this. A plane like this. Okay. Because this is hydrogen, this is hydrogen. A plane like this. How many planes? 3 sigma plane. Therefore it has sigma B. Therefore it is C3. It is C3. Okay. Now we can go to another example. C double bond H, 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 that is CH2 double bond CH2. Planar, it's a planar. Whether it has principal axis, CN axis, yes. This is a CN axis. You check, we have 4 types of axis. You have X axis, Y axis, Z axis. Which is principal axis? Yes. Imagine it is a square. It is a square. Therefore, you have a principal axis like this. That is C4. Whether you have C2, yes. This is C2. This is C2. And you have 4C2. Therefore, it belongs to D group. Now, it has sigma plane. Sigma plane means imagine a plane perpendicular to your principal axis. This is your principal axis. A plane should be like this. Yes, it has a plane because it is a planar molecule. Every planar molecule has a plane, molecular plane. Therefore, it has sigma h also. Therefore, it is D4H. The molecule is D4H. Now, another one. H2O. H2O. OH. It's a planar. Do you have this type of axis? No. Do you have this type of axis? No. But you have this type of axis. Okay. You have this type of axis, that is C2 axis. Do you have C2? Do you have 2C2? No. Now, do you have a molecular, do you have a sigma plane? Sigma plane means your axis like this. This is your axis, therefore you have a plane like this. No. No sigma h. No sigma h. Do you have a vertical plane? Yes. Sigma b. Therefore it is C2b. Next is CH2Cl2. CH2Cl2, very careful. CH2Cl2. that is Cl, H, sorry, H, that is H and H like this, Cl here, Cl here, Cl here, Cl here. You have an axis like this, because when you rotate 180 C2 degree, when you rotate C2 degree, this Cl come here, this Cl come here, this H come here, this H come here. Therefore, it has a C2 axis, not round. C2 axis, and it has, I said to you, this is like this, this is like this. Okay, H. It has a C2 axis, H here, or Cl here, H here. It has a C2 axis. Now you have a plane cutting like this. A plane cutting this H and H. That is perpendicular to your C2 axis. Perpendicular to sorry, not perpendicular, C2 axis, containing C2 axis. Therefore, sigma C2. Therefore, remember, CH4 tetrahedral, CHCl3 or ClCH3, C3b, CH2Cl2 type, C2v, CH2Clbr, C2 only C2 because Clbr, CHClBr iodine C1. Remember the students this. Okay, remember CH4 tetrahedral, this is C3v, this is C2v, this is C2, this is C1. Okay, yes. Another one, BF3, that is BFD3H, BF2Cl, that is BFFCl, this is C2V, BFClBr, ClFBr, this is CS. Okay. Now a last example. We will finish it. Cobalt En thrice 3 plus cobalt okay, this that side En, one En group like this, one En like this, one En like this. Remember, this molecule has a C4 axis, and you have C2 axis like this, one C2, second C2, third C2, fourth C2, one C2, second C2, third C2, fourth C2, 4 C2 perpendicular because C4 is. But you have no plane because when you cut the plane, suppose this is your plane, perpendicular plane. If you take it is a plane, upside, in the upside right side is Cn. Okay, when you take this plane, okay, this is from back side to this, here it is from front side to this. Therefore, there is no plane, no sigma h, because it is this connection from here to back side, this connection from here to front side. Therefore, no sigma h, no sigma v. Therefore, it has C4 only. See this only C4 and 4C2. Therefore, it is D4. Point group of this molecule is D4. Okay, these are some previous questions. You do more the examples. If you find any difficulty, we can discuss it. Okay? Thank you for watching.